Thank you very much. Do you hear me well? Yes? Yes? Okay, so thank you for the kind introduction, and thank you especially for inviting me to join this very interesting summer school on a topic that is more and more discussed in Brussels and in other places throughout Europe. Today, I will try to, let's say, discuss with you a bit of regulation from, I would say, mostly an economic point of view, a conceptual point of view. I think it's a nice idea, given that many of you have mostly an engineering background, and sometimes it's useful to go back to the fundamental ideas in order to understand better where to develop technical solutions. You have to understand the big problems and the big picture in order to, I think, explore the solutions. So this is the outline for our chat this morning. I will start with a few questions just to warm up, to break the ice, and then I will try to walk with you along this path where we will see how electricity as a peculiar commodity creates the need for rules, for specific rules to support its trading, and how the emergence of new types of transactions actually calls for the adoption of new rules, for the evolution of, let's say, the regulatory framework in place. So let's start, and I want you to be as interactive as possible. What are transaction costs? Anybody, because my talk will revolve a bit around this concept. For institutional economists, this is a quite easy question, but I would like to know if you have any idea of what is a transaction cost. Don't be shy. I assume that at least some of you has a vague idea of what they are. I cannot, please.
Transaction cost, we usually say that when you see the transaction happen, the bottom line will be cost. There are some costs, there are some benefits should overweigh the cost based on the transaction cost theory, it can happen.
No.
I did finish.
You finished already? Okay, so I arrived too late. Okay, anybody else? Any example, any concrete example of transaction cost you have in mind? Look at the picture. It should be revealing. These people are where? Where are they? In a shopping center, in a mall, so they are going to buy something. They are going to trade, to buy and exchange money. And what are the costs they are going to bear in order to get the stuff they are going to buy? Good answer. So not only the money they will give to the seller, but also their time to reach the mall, the time to look for all the various options they have available in the mall. But not only that, imagine that you buy some shoes and then you try the shoes and you go home. They do not work well for you. They have maybe to go back. They have to discuss with the shopper, with the seller, in order to get the money back or another pair of shoes. So transaction costs are all of this. It's what you need to pay, not only in currency, but let's say in any other type of cost in order to have your stuff. And sometimes this is quite a significant cost. Sometimes this is much bigger than the cost, than the money you give to the seller. There is, I would say, no consensus on the classification, of precise classification of transaction cost, but you could argue quite well, for our purposes is enough, that there are transaction costs can be divided in research, and so cost, and information cost. Then you have the cost associated with the bargaining with the counterpart to the trade, to take decisions, and then enforcement or settlement post-purchase costs. So this is something to keep in mind. Second question, what is a peer? Because we are discussing peer-to-peer since a couple of days. Anybody of you willing to provide an idea? Please, Nicole. Exactly. A peer is, a peer against another peer, because it's not something that you can define in isolation, are subjects that are equal, not necessarily identical. And we have a fantastic picture from the House of Lords, which is full of peers, because they are all on the same level, of course, below the king or the queen. Peer-to-peer, it's a type of relation. It's not something special in the old days, in pre-industrial society, but then, of course, with the development of the industrial economy in, let's say, 20th century, peer-to-peer transactions, peer-to-peer trade became, let's say, a niche. It was much replaced by business-to-consumer interaction or business-to-business interaction, but it's now, again, there is, again, increasing interest for it, and, of course, the sharing economy, but before that, all the peer-to-peer in information technology is a good example of this. And then, my last question, and then I will not bother you anymore. What's the difference between exchanging apples and electricity with your neighbors? Ideas. What type of problems exist in one case that are irrelevant in the other? Please.
With the apple, you don't have to eat it immediately.
Good point. So you can store the apples for later use. Anna? Okay, this is good. So it's clear, because we can, apples usually are ready in September, October, but we can eat all the year long. Other things. Get?
Rotten apples, but there's no rotten electricity.
Okay.
You have different qualities involved for apples, but you don't have the difference between electricity. They're all electrons which are the same.
Interesting. I would say this could be the view of an electrical engineer, but for some type of people, and we will come back to this later, this might be not totally true.
Apples, you can easily get them, and the transport. I mean, I don't know, but the way you deliver or accept is easy. While electricity, you don't know how to. You need the infrastructure to.
Very good point. A common infrastructure. You can go to your neighbor and it can give you the apple hand by hand or in a bag, whatever. For electricity, you need a specific infrastructure. And unless you are in a direct line between your neighbor, this network connects not only you and your neighbor, but also a lot of other people. Anybody else? Nicole, and then...
I guess that's not really equal frameworks about exchanging apples with your neighbors.
Well, you could say that in many countries, this is a non-commercial transaction. It's like it's irrelevant from a commercial point of view. It's not, if it's not the business of your neighbor. Of course, if your neighbor is a big apple producer, then different rules may apply, but in this case, it's no more a peer. So yes and no, I would say. Last comment, and then we wrap up.
Any kind of apple can be traded and can be accepted as an apple, while the specification, the quality, and the characteristics of the electricity that you produce may not be accepted by your neighbor.
Well, suppose that I like a golden apple, but not another name, Marilena apples. Yes and no. Also, you have many types of apples. You may have many types of electricity if you go beyond, let's say, the pure electric perspective.
You're all talking about the red apple. It's like this much or this much. This is still an apple, but that cannot be.
Interesting, because if you go to your neighbor, you can see the apple. And this simplifies or reduces one of the transaction costs that I mentioned you before. Looking for the information. You go, you see the apples. More or less, you can understand immediately the quality of the apples. Maybe there is a bug inside, but usually the bug needs to enter somewhere so you can see the hole. For electricity, is it so easy to understand the quality? If you look at your neighbor, he has a PV plant, but maybe there are other aspects, other qualitative aspects that you do not detect immediately. Good point. I think that you answered very well to this last question, so maybe my business for today is over. Joking. Let's try to debrief your answers and to put them in a story. I hope I will not bother you with too many introductory stuff, but here is exactly the answers you gave me a few seconds ago, that electricity is a very peculiar commodity, is a very peculiar thing, and for this reason it's difficult to trade. We have a variable demand, so we do not ask for for electricity in the same way all the time. Our demand for electricity is quite inelastic to prices. So, okay, even if prices double, you would buy probably more or less the same amount of electricity. It's very difficult to store electricity. Contrary to apples, you need to consume almost instantaneously, unless you have some storage facility. And very important, you have the physical network that is needed for delivery. And interesting, we mentioned this also yesterday and during the presentation of the lady from Vito. The use of the electricity infrastructure is full of externalities. So if you start to inject or withdraw electricity from the grid, this will affect the possibilities for other people to inject or withdraw electricity from the same grid. And this is probably not the case at all for trading apples with your neighbors, but sometimes different also from other network industries. And then we have plenty of scale and scope economies. So to produce electricity, it's easier, it's cheaper if you produce a lot of electricity rather than a small amount. And sometimes there are advantages associated not only to produce, to generate electricity, but to trade, to transport it as well. All of these make electricity historically quite a peculiar commodity and led, well, this is clearly a bit of a joke, to the old good days of the legal monopolies. After an initial period of competition, electricity was something not traded on a market. It was given the task of producing and delivering electricity to a single entity, and this entity was in charge of all the supply chain, if you want, from the generation, transmission, distribution, and sale or delivery to the final customer. So vertical integration, no space for decentralized transactions. This legal monopoly was full of engineers defining the optimal expansion plan of the generation and grid, and then operating it according to technical efficiency. Customers were users or even loads. So if you start also from a semantic point of view, calling customers loads, it really means that we are very far from a transaction-based perspective. And in this context, where there is no market, no role for market, Well, we have economic regulation or public ownership in many European cases to replace competition. Competition is usually pursued because under certain circumstances it ensure the best outcomes for the customers. In this case, there is no market, there is no possibility to trade electricity, it was too difficult. Then we have only one company and we regulate it in order to ensure that customers or loads benefit from an efficient and reliable service. Of course, if there are questions, comments, please raise your hand. But then things started to change, but not so long time ago. I would say in the 80s, 90s, there were the first attempts to introduce transactions in electricity. We can call it decentralization 1.0. And you give the right to sell megawatts. So you start opening generation for competition. Why? Because technology is changing and you have now new tools to manage the complex product that electricity is. We have, CCGT that reduces economies of scale in power generation. We have the digitalization of the transmission level and the creation of the first platforms where you can trade electricity. And then, of course, there is also a policy consensus in favor of liberalization and restructuring and against old monopolies. In this first era of, let's say, electricity trades, electricity transactions, many markets design have to be developed. Because an important point that I want you to remember is that there are many possible solutions, many possible rules to support trade in electricity. Many market designs are possible. Europe is going in one direction, but in the US you have other options. Usually these markets to trade electricity at the wholesale level are more than one, in a sequence to enable gradually to reach the real time. And normally these market designs simplify the physical network. So you told me earlier, you need an infrastructure to deliver electricity. But of course, this physical infrastructure creates complexities for trading. The choice in the 90s, in 2000, was often to simplify the description, let's say the view of the infrastructure, and to create so-called bidding zone. Maybe we have a picture here, yes. You see, you make assumptions. This is your network. In theory, as the lady from Vito said, it should be optimal. We should consider the constraints, but this often complicates trade. And so, in many cases, in the 90s, it was said, well, let's consider the entire network of Italy, for instance, or let's say better for France, as a copper plate. So we do not care about physical constraints in the moment of trade. We carry it closer to real time and we give the role to system operators to reconnect the commercial trades with the physical reality of the grid. At the same time, more or less, we also observed the initial possibility to, let's say, trade electricity with customers, but only in one direction. You buy from a retailer, from a professional company, to satisfy your needs as a final customer. So, again, the peers in this moment, in the liberalization of the 90s or the 2000s, can just purchase electricity from a retailer. They have now the right to switch from a retailer, from, let's say, the incumbent, to another one. But this is basically all they can do. They normally look at the price, maybe some bundle offered by the suppliers. All the rest is fixed. And in particular, we preserve the role, we mentioned yesterday, I think, of the supplier, of the single supplier. There is one supplier per customer. This supplier manages all the interface, all the relation of the customer with the rest of the system. Is in charge for procuring electricity, dealing with imbalances, and whatever. The customer simply has to pay the bill, and in exchange for that, he can consume any amount of electricity he wants. A first, let's say, evolution of this, a first change to this state of affair, or improvement better, is the deployment of smart meters that started a bit after the liberalization period. Actually, in some countries like Germany, is not there at all. It gives more freedom, more degrees of freedom, because with a smart meter, you can, for instance, offer more sophisticated tariffs. You can simplify the switching from a supplier to the other, and so on. But still, this freedom for the peers in the electricity system are somehow limited. This is yesterday. Now let's come to the innovations of today and the new transactions that are emerging. So we first see, at the beginning, electricity is too difficult, too complex as a commodity. We do not trade it. Then we allow for trading at the wholesale level, often simplifying the complexity of the electricity system. We enable final customers, households, businesses to purchase electricity and to choose their own supplier, but not more. Now we go to new types of transaction involving retail size assets, so the PV you have on your rooftop or your electric vehicle battery, and peers. This happened, in a context of a changing electricity system is becoming more sophisticated. We have the so-called 3Ds, decentralization, more generation units spread all over the electricity system. We have decarbonization, so the deployment of intermittent renewables, and then digitalization. So the creation of a layer, of a ICT layer on top of the physical layer of the electricity system. And digitalization is important not only for large assets, for transmission, for big power plants, but also at the distribution level, also in your homes. And then we have a final, let's say, driver for change is electrification. So the increasing use of electricity as a vector for other end uses beyond the traditional one, and in particular for heating and for mobility. Electrification is now foreseen, I would say, as one of the main drivers to decarbonize, to reach deep decarbonization. And if you want, it's becoming the currency in which to pay for, let's say, energy services in increasingly integrated energy sectors at the local level. Okay, here a few reflections about digitalization. Obviously, in essence, digitalization means that we have larger availability and usability of data. We can monitor and control the physical assets. And interestingly, we are expanding this ability really to the smallest assets. In an economic point of view, you see, you reduce cost, in particular transaction costs. Before, some of them really are slammed by digitalization because information is easy to check, decisions are easier to implement, and also enforcement of decisions becomes easier. All of these, as I said, can reduce cost in existing activities, but also, so metering your consumption, for instance, but also enabling new transaction and new business models. And this is exactly what this school is about is peer-to-peer or peer-to-X. We will now look at it. And interesting is also this point.
What do you mean peer-to-X?
We will show you. It's to differentiate it from peer-to-peer, because peer-to-peer, as we said, is a transaction between two parties that are equal, although not necessarily identical. Sometimes these transactions are not really peer-to-peer. There is one peer in the sense of a household, a small business, so a non-professional party that interact with someone else that is not, let's say, on the same level, like the TSO or the DSO that the lady from Vito was mentioning yesterday. Speaking about peer-to-peer in the provision of ancillary services is not, let's say, correct, because the DSO is definitely not a peer of the network user. Okay, if there are no questions, let's try to have a look at the various peer-to-peer and peer-to-X type of transactions that we see all around emerging in the electricity sector. Well, I call it many shades of peer-to-peer, as also I think was Anna yesterday mentioning. There is a big discussion, a big debate about peer-to-peer, but if you many implementation projects, research studies on it, but if you start to look at them closer, you see that they are not always the same. They are different under many aspects, either the product, either the infrastructure they rely upon, the intermediaries that are involved. So that's why we said many shades of peer-to-peer. Important is to remember this peer, this concept of peer we discussed earlier. The parties are equal, but I would say in the normal meaning of the term, they are also small, non-professional actors. We have producers that are on the same size of the buyer. This is definitely something new for the electricity sector. There are many reasons behind the growing interest for peer-to-peer. These are basically them, the deployment of distributed generation, so innovation in PV and massive deployment of PV, of small-scale PV in the past decade, but also the phase-out of support schemes for them, for renewables. This is, I suppose, one of the main drivers for pushing for the adoption of peer-to-peer, but also customer stratification. What do I mean with customer stratification? That in the emerging electricity system, customers are not the same. They have very differentiated, let's say, preferences in terms of electricity. And so they can be stratified, they can be segmented. This could be because some of you are more interested in green electricity than others, or in local electricity than others. But also it can be related to the fact that some of you has a big house that owns and in which installed distributed generation, storage, EV, and others live in a small flat that they do not own. So they have really different set of appliances, different set of devices that can consume or produce electricity. Of course, dissatisfaction with traditional suppliers, with a multinational company offering electricity, and then, as I said, electrification of end users. When you consume no more than, in the past, maybe a family could consume 2 or 3 megawatt hour in a year, so the economic value is still relatively small. But if with the electrification of heating and transport, your household will consume 10, 12, 15 megawatt hour, of course, it becomes more interesting to be active in the electricity sector. And then, where do we see peer-to-peer, these new transactions at work? Yesterday, some of you said there are a lot of studies, but little implementation. Yes and no, in the sense that there are a few cases of implementation. Let's say there are three, basically, in regulatory sandboxes. Peer-to-peer via digital platforms established by asset-light intermediaries, and then also energy sharing or peer-to-peer energy within bottom-up communities. Let's have a look at them, also with some specific cases. Regulatory sandboxes. Peer-to-peer exchanges of electricity peer-to-peer is clearly something new, we said that, and it's often not directly allowed by regulation. That's why in many parts of the world we see trials, we see pilot projects in closed spaces where some of the rules that apply to the electricity sector are suspended or are temporarily changed. Some of you mentioned Community Plus in Great Britain yesterday. And other examples are Brooklyn Microgrid, a pioneer in this field some years ago, but actually I think they did not really implement that much after all. A very interesting experiment in Switzerland. I think it's one of the most well documented in Europe, and I really invite you to look at the research that has been published about it. And then there is another interesting case, in Australia. This Renew Nexus, it's led by Power Ledger in Fremantle, close a neighborhood of Perth in Australia. What are the characteristics of all these cases of peer-to-peer? As I said, they are closed spaces where some of the rules are suspended. Peers can enroll in these sandboxes, but they do not usually lead the process. It's a technology company, it's a university that normally lead the process. We are speaking about small scale cases, really at the local level, a neighborhood, typically a building. There is sometimes the involvement of blockchain. Actually, peer-to-peer has been associated with the increasing interest for blockchain some years ago. Now I think that this interest is a bit diverging, so we can speak about peer-to-peer also without mentioning blockchain at all. And it's important, these two actors are normally involved as well in these pilots. So the local utility, so the company responsible for the infrastructure at the local level, the wires, and the supplier. So you need these two actors because then your sandbox still must interact with the rest of the electricity system. Results of these projects are interesting. You see that there is an interest by the people involved. They like to interact, although after some months, usually interest in this novelty declines. People are ready to pay a bit more for the electricity of their neighbors, but not that much. And in some cases, depending on the way the tariff, the recovery of the cost is organized, you may end up with little interest either from the peers on the consumption side or the peers on the production side. Then, peer-to-peer within a platform. This is a different case that we see in Europe, for instance, where the two examples come from, the Netherlands and Belgium. Here, the idea is to have an open space. It's the opposite of the regulatory sandbox. You establish a digital platform and you allow users of the platform to trade electricity. But actually, these trades are supported by the entity that established the platform, and then in the end interacts with the rest of the electricity system. Of course, peers must respect the rules of the platform. They may be interested in the qualities of electricity, so that's why my reaction to get at the beginning. With digitalization, you can attach additional characteristics, of course, in a virtual sense, to the electricity you trade. But then also this implementation of peer-to-peer still must confront the rest of the system. And so basically the companies offering this service are in the end a kind of energy retailer, asset light, because they don't own generation assets. They simply support the trades of the peers and then eventually cover the gaps or sell outside the surplus electricity of the peers. Finally, bottom-up communities. Sometimes we see local communities, genuine communities, willing to explore these opportunities. There are various cases around the world. In some cases, it's more, let's say, what is often called energy sharing or collective self-consumption, which is by now legally possible in most countries of the European Union. And it's actually the example in Partage Elec. So you have a community of people that decide to invest in one generation asset in a building, and then in the neighborhood, it could be the same building or the same piece of the distribution network, they can self-consume collectively the energy output of that plant. In other cases, like in Australia, this Beehive project close to Newcastle, the idea is to create community assets, but also to integrate individual assets of the peers involved, the community members involved, and allow them to trade. Again, however, with the support of some third parties that provide the digital platform. Any question on this? Otherwise, we go to Peer-to-X. Okay, Peer-to-X, as I said, peers that offer something to the rest of the system. In the previous era, if you want, peers were only absorbing energy from large power plants. Now they are increasingly interested, but also able to provide services to the rest of the system. We call it, as I said, peer-to-X because the other side of the transaction is not a peer anymore, it's something bigger, is typically the system operator. It's this other part of the transaction that normally facilitate the trade. There are many examples well established, some of them, other emerging only recently. We call it power to system via feed-in tariff, power to grid via aggregators or local flexibility markets, and then peer to system with an integrator. Let's have a look at them. Feed-in tariffs. This is actually a well-established type of transaction. Final users become prosumers, install their PV unit, their wind turbine, whatever. They start to produce a surplus of electricity. They inject into the public grid, and then there is a professional entity, often is a public company, that take off such energy and remunerate the prosumers. And this is actually quite a peer-friendly type of transaction. Feed-in tariffs were very effective in promoting the activations of customers 10 years ago. Of course, with the phase-out of support measures, this type of mechanism must evolve. just one comment, I said it's particularly peer-friendly because from the point of view of the customer, there is not much to do. You install your plant and then you produce whenever you want. You do not care about the implications for the system. Then, one step more sophisticated, peer-to-grid. Here you do not sell, let's say, just energy. You provide flexibility to the grid. But again, this, on the other side, you have either an aggregator or a local flexibility market. The reasons for the growing interest in this type of transactions are obvious. With the systems, with the electricity system, with a large share of renewables and with the electrification of end users, you cannot continue with the traditional approach to network expansion. Would become an operation, would become too expensive, the old approach of fit and forget. It's important to manage the grid, to procure services from the units, from the assets connected to the grid. Here, I must confess that for the moment, retail customers are still at the edge of this type of transactions. Aggregation for the moment and the provision of flexibility on local markets is mostly done by, let's say, peers a bit bigger, so commercial or industrial sites. There are still many challenges to enable households to provide services to the grids. Couple of examples. Voltalis is the largest aggregator in Europe, in France, sorry. And then Picoflex is a software company in Great Britain that cooperates with distribution companies to create these local flexibility markets. Experience so far is positive, but not that positive. I understand that some distribution companies in Great Britain start to observe that the cost of procuring these services in some cases is not much smaller than expanding the grid. So we have still to understand the role of this option in the future. And finally, this peer-to system with an integrator. In the previous case, there was an aggregator managing eventually the consumption, the load of the customer, and extracting flexibility to it to resell it to the system operator. Here, we have a slightly different type of interactions in which a company, that often is a software company, but sometimes there is a role also for manufacturers, provide assets to the customer and energy to run those assets, but ask the customer to be flexible in the use. He said, if I can use, I can manage those assets at your place, then I will take care of the supply of energy and charge you a bit less. There are some examples in Europe emerging. Sonnen community in Germany, it's a provider of batteries and PV system that creates, let's say, a distributed networks of prosumages that are used also to sell services to the grids. And then another interesting example is this Octopus Tesla energy plan. So an innovative retailer in GB partnering with a manufacturer, Tesla, and offering a package to his own customers where he can modulate the energy consumption of the batteries and in the EV or the Powerwall to reduce the cost of the energy supply to the final customer. Yeah, that's it. It's an overview of these emerging types. Now let's try to conclude with a look at the rules and how the rules should change in order to, or might change, to support these new transactions. Well, we said trading for peers is not easy. Peers are small, are non-professional, they trade small quantities of energy, and so for them, transaction cost can be relevant, even if there is even if the digital technologies can help them. Just to make it visible graphically, with a colleague, we decided, let's think, what do we need to support this type of transaction, peer-to-peer or peer-to-X? Well, we need three pillars, we call it. We need a pricing mechanism that provides incentives to the peers, so induce them to invest in the assets and to operate them in a good way. Then we need a matching loop, that a platform, possibly, that reduce this transaction cost. And then finally, we have this delivery loop. The delivery loop is basically the infrastructure, the distribution grid that you need to enable peers to sell their surplus or to buy from other peers. If you think in these terms, it's clear that peers cannot do it alone, because there is still this loop, this delivery loop to arrange. There is this matching loop to arrange, and also the pricing mechanism could be tricky. That's why, as we saw by going through the various cases, there is always a role for a third party that provides either the digital platform, either the interface with the rest of the energy system. The business case is still unclear, in the sense that many people say, I would like to trade peer-to-peer, but then when you see the proceeds of those transactions, you start to wonder whether there is enough value created. And then finally, a final comment, clearly, these three pillars must keep the roof even. So we need governance to ensure alignment. Regulation. Why regulation is often said to be a barrier to these new types of transactions? Well, clearly because the delivery loop in electricity, it's a public infrastructure. We said it, you said it at the beginning of this talk, that we use a common infrastructure. The common infrastructure is heavily regulated. And it's heavily regulated, keeping in mind the way to organize the industry and the type of transactions of the past. So the transaction between large professionals and the transactions unidirectional between large professionals, the retailers, and the final customers. There are many examples of regulation that hinder the implementation of this type of new transactions. I cannot provide you with an extensive list of them. I will just make three examples. The cascading principle in network charges. How many of you are aware of this cascading principle? One? Okay, so how do you allocate the cost of the grid to the single network users? In the past, it was said, since electricity comes always from large power plants, and then go via the transmission grid, via the distribution grid, finally reaching the customer, it was said, well, it makes sense to allocate the joint cost of all the grid according to the voltage level to which the customer is connected. So a customer connected to the high voltage grid, for instance, a large factory, was charged a network tariff proportional, because then of course there are many other complexities, but proportional to the share of the cost of the entire grid that are referred only to the distributions, to the transmission segment. Its network charge was not, let's say, proportional to the cost also of the distribution, because it was assumed this customer will not use the distribution grid, so it does not make sense to attribute him the cost of distribution grids, only the cost of transmission. Whereas a customer connected to the distribution grid, to the low voltage, his or her network tariff was said to be proportional also to the cost of the distribution grid, not only of the transmission, because it was going to use both. In this way, it's clear that customers connected to the distribution tend to pay higher network charges than customers connected at the transmission grid or at higher voltage levels. This principle makes totally sense when you have the old electricity system with electricity flowing from centralized power plants to the final customer connected at the low voltage level. But you may start to wonder whether it makes sense, whether it is a barrier to overcome for peer-to-peer, because assume you trade with your neighbors using only a small piece of the distribution grid, then why do you need to pay for also for the transmission grid? You see, I think this is a very good example. A rule that made sense in the past, now its raison d'etre is not so strong anymore, and if we keep it, it can undermine some of these transactions, because if you have this large, big network charge, probably also the cost effectiveness, the competitiveness of the energy that your neighbor will sell to you is not so big. But we could make other examples. This idea of one meter, one customer, one supplier. It's the idea of, let's say, due to the possibilities, the options that were available in the 90s, it was not easy to measure the consumption of each customer, to collect the information, to settle the transaction, to reconcile the consumption metered with the transaction at the wholesale level, etc. So it was said, let's make it simple. We have only one meter for one customer and only one supplier taking care of that relation. At the beginning, we were using even load profiling to estimate the way the customer was consuming energy. Now we have smart meters providing real data on consumption. But you see, this was a choice that made sense in a world where digital technologies were still rudimentary and information was costly to procure. Now, well, you don't know. Maybe with all the developments in ICT, it can make sense to break this rule and have sub-meters and to attribute a role, a value, to recognize the role of those meters. Last example that I want to make, also because time is running, access to ancillary service markets. So I'm not talking about energy, but services, system services. Until recently in Italy, in order to enter some of these markets, you need to have a power connection of at least 10 megawatt volt ampere, and you could not be a wind farm. So there were technologies and minimum sizes to respect in order to provide services to these markets. And clearly this is another rule that is not supportive of what I call power to peer-to-X transactions. In this context, it's clear that legacy regulation tend to block innovation and to push it at the edge of the public grid. So there are, from a, let's say, business point of view, since you cannot do much within the regulated network, you try to develop solutions at the customer premises. So home energy management systems, or microgrids. There is a growing interest in the US, in Europe, for microgrids, which are simply realities outside of the public domain and the public regulation. I will we'll close with some additional thoughts along this line. We said just that regulation can block this new type of transactions. And in a sense, you could say that regulation is a problem. You could also see regulation, nevertheless, as a barrier, a barricade against the bandits. This was the title to close that I thought before, but then I said maybe it's too provocative. Let's remove it. Regulation in electricity often has to deliver many goals, many conflicting goals. For instance, the example again, if you were yesterday listening to Anna, the very complicated tariff structure in Colombia. Why so complicated? Because the regulator there wants to achieve two goals: cost recovery for the local utility, but also intervene against, let's say, energy poverty, or subsidize, for political reason, lower income consumers. And this is why he made choices, he chose a complicated tariff structure. These new transactions that we see emerging can challenge these regulatory solutions of the past. In particular, they can try to bypass existing regulation and to shift some of the costs of the system to the actors that are less active. In this sense, some of the peers that are entering these new worlds are like bandits. That's why my title, or pirates, because they innovate, but they innovate also because sometimes they want to escape the cage that the regulators and policymakers developed over the past. And this can create problems. Just to provide you another example in the electricity sector, yesterday the lady from Vito mentioned a compensation scheme. There is this big debate in Europe whether independent aggregators should compensate the retailer of their customers when they activate demand response. Some of them say, no, we don't, because this energy was not yet consumed. Others say, well, but this energy was procured by the retailer. So some rules can block new type of transactions, but not necessarily are efficient or fair. So we need to keep this in mind. So in general, and this is my closing remark, we need to reassess the regulation of the electricity sector because it was developed in a different era when technology and options were different. We need to reassess this, and in particular, I think we need to rethink two elements. How we protect customers. In the past, it was by introducing tariffs, cross-subsidization, and the like. Maybe the future is different. Maybe it's via empowerment. And then another problem that I didn't develop it much, but it's still really big, very important, is the integration of all these new transactions within the sequence of markets that you see here. Sorry. In Europe, but all over the world, there is no single electricity market. There is a sequence of markets. They are connected. Now, the emergence, for instance, of these local flexibility markets create an additional complexity because we need to put them somewhere in this kind of, in this graph. And there are advantages and disadvantages of the various options. Okay, and with this I have concluded what I wanted to tell you. There are some readings if you want. And if you want to know more and to engage in this kind of topics, there is a global observatory led by University College London, where a lot of people looking at this topic are involved. Thank you very much.